Assalamualaikum and hi everyone. We continue with the third video for topic 1 and subtopic 1.1. This time, our learning outcome is at the end of the lesson, students should be able to D. Find one-sided limits as shown below.
One-sided limits. A one-sided limit is the value that fx approaches as the x value approach from one side only, either from the left side of x or from the right side of x. Now we refer to the graph. Please stay to the left of x equal to 0. So here we notice that fx approaches 0 as x approaches 0 from the left. It means the function or the yellow line is moving in towards a value of 0 when we get closer and closer to x equal to 0. Likewise, if we stay to the right of x equal to 0, fx approaches 1 as x approaches 0 from the right. It means the function or the blue line is moving in towards a value of 1 when we get closer and closer to the x equal to 0. Therefore, a one-sided limit can either be a right-hand limit or a left-hand limit. Then, the right-hand limit can be written as state and read as the limit of fx as x approaches a from the right is L. Please take note, the sign plus or positive here indicates that it is from the right, while the left-hand limit can be written as state and read as the limit of fx as x approaches a from the left is m. Note that the sign of minus or negative here is shown it is from the left. Example 8. We are asked to find limit of fx as x approaches 4 from right and limit of fx x approaches 4 from left by using this graph. Okay, so for A, we stay to the right of x equal to 4 as x goes closer and closer to 4 from right. We can see fx or this blue graph is moving down and approaching to 2. Therefore, limit of fx x approaches 4 from right is 2. Next, B. Now we stay from the left of x equal to 4. Here we notice that as x goes closer and closer to 4 from the left, fx or this green line is moving up and approaching to 4. Therefore, limit of fx x approaches 4 from left is 4. So, hopefully you have understood about what is the right hand limit and the left hand limit. And take note, the sign plus means it is from the right, and the sign minus or negative means it is from the left. Now we proceed to example number 9, which is the same as the example that we have learned before. As we all already know, the limit can be determined or evaluated by substituting a push value of x into function fx. If you get a value, it means we have got the required limit value. Otherwise, if we get an indeterminate form, 0 for 0, so we need to use another method, either factorization or multiplication of conjugates. Okay, let's try this example one by one. Okay, first we try A. We are given limit of x squared minus 3x plus 4 as x approaches 1 from right. So we substitute 1 into the quadratic function and get the limit value is 2. We proceed with question B. We are given limit of x squared minus x minus 2 over x plus 1 as x approaches 2 from left. First, we try to substitute 2 and see what we get. Okay, we get 0 over 3, which it can be solved, and the limit value is 0. Okay, alternative for B. Since we have a rational function and the numerator has quadratic expression, then we factorize the quadratic expression and obtain like this. We notice that we have x plus 1 on the top and bottom of the fraction. So we can cancel x plus 1, and leave limit of x minus 2 as x approaches 2 from left. Now we substitute 2, simplify, and get 0. Okay, for C, it's same with B, which we have quadratic expression on the top. Okay, so better we factorize the quadratic expression and get limit of x minus 5 times x plus 3 over x minus 5 as x which is 5 from right. So here we notice that we can cancel x minus 5, then just leave limit of x plus 3 as x which is 5 from right. Okay, substitute 5 and get the limit value is 8.
Example 10. This time, we are asked to find one-sided limit from piecewise functions. It may seem difficult, but it is actually simple if we really understand about one-sided limit. The one thing you need to worry about is that you need to choose the correct function based on the requested limit, because the piecewise function have multiple of functions. Let us look at example A. We are given fx equal to x squared when x is less or equal to 3, and fx is equal to 2x when x is greater than 3. If a question that has the piecewise function like this, it is better if we change this piecewise function on the real number line. First, we draw a number line like this. Why it is 3? Because our mean number here is 3. Since fx equal to x squared is defined when x is less or equal to 3, so we draw an arrow line showing that x is less or equal to 3. This circle is a dense circle because our inequality has equal, and put fx equal to x squared. Then we draw an arrow line for the second function that's showing x greater than 3, and this circle is an empty circle because our inequality has no equal, and put fx equal to x. Okay, so now we can find the requested limit. Number 1, we need to find limit of fx. X approaches 3 from left. Okay, so we stay to the left of x equal to 3. We notice that the correct function that we need to use when x approaches 3 from left is x squared. So we replace fx with x squared. Next, as usual, we substitute the approach value 3 into x squared and get the limit of fx. X approaches 3 from left is 9. Okay, next, we find limit of fx. X approaches 3 from right. Same, we stay to the right of x equal to 3, and notice that the function when x approaches 3 from right is 2x. So we replace fx with 2x, then substitute 3 into x and get the limit of fx. X approaches 3 from right is 6. B, we have 3 different functions: constant functions, quadratic, and linear function in one function fx. That's why it is called a piecewise function. Same as the previous example, better we change or we plot these functions on a real number line. Okay, so we draw a number line as shown. Why do we put negative 2 and 2 here? Because the main number in these functions are negative 2 and 2. Okay, so now we plot or we draw an arrow line for the first function. We have x less or equal to negative 2. So the arrow line showing like this. Okay, so then circle because the inequality has equal, and we put the function fx equal to 2. The second function is x squared minus 2 when x is greater than negative 2 and less or equal to 2. So the arrow line is like this. Okay, so at negative 2 is an empty circle because this inequality has no equal. At x equal to 2, it is a dense circle because this inequality has equal. So then the function is x squared minus 2. And the third function is defined when x greater than 2. So the arrow line showing greater than 2. It is an empty circle because here is no equal. And the function is 5 minus x. Okay. Actually, this number line is not compulsory. Yeah? It is just to prevent us from choosing the wrong functions when we want to find one-sided limit. Okay, because when you draw this number line, okay, it is really clear Okay, which function we should choose and use when we want to find the right hand limit or the left hand limit. Okay, let's try the first limit. Okay, so we are asked to find limit of fx when x approaches -2 from left. So we stay to the left of x equal to -2, and we notice that the function is fx equal to 2. Okay, so we replace fx with 2, and fx is a constant function, so we know the limit value of this fx when x is approaches -2 from left is the constant 2. Let's try number 2. We are asked to find limit of fx, x approaches -2 from right. So we stay to the right of x equal to -2. Okay, so for this one, we need to choose the function that closest to -2. So the closest function here is fx equal to x squared minus 2. Okay, so we replace fx by x squared minus 2. Substitute -2 into the function and get the limit of fx, x approaches -2 from right is 2. For B3, we want to find limit of fx, x approaches 2 from left. So we stay to the left of x equal to 2. As the previous example, we need to choose the closest function. Okay, for x approaches 2 from left. So we have fx equal to x squared minus 2. So now we replace fx by x squared minus 2. Then substitute 2 into x squared minus 2 and get 2 squared minus 2 or 4 minus 2. And the limit of fx, x approaches 2 from left is equal to 2. Okay. Last, number 4. Find limit fx as x approaches 2 from right. Okay, so now we stay to the right of x equal to 2. So we notice that the function when x approaches 2 from right is 5 minus x. Okay, so we replace fx by 5 minus x. Substitute x. It is 5 minus 2. And the limit value is 3. Okay, so it's very simple. Okay, if you really understand okay what is a right hand limit and what is the left hand limit. Okay, so please take note. Please take note for the right hand limit we have sign plus or positive like this, and for the left hand limit we have the sign minus or negative. Okay, so that's all for this video.